The working principle of an electric motor that you couldn't figure out in years at school. Today I'll explain it clearly in just 2 minutes. This is an iron rod. If you wrap coils of wire around it and pass a current through, the rod becomes an electromagnet. If you change the direction of the current, the direction of the magnetic field in the iron rod will also change accordingly. In this way, we have an electromagnet that can change its magnetic field at will. It has the same properties as a permanent magnet, like poles repel, and unlike poles attract. Now, let's change the shape of this electromagnet and install a rotating shaft in the middle so it can spin around its axis. You can call this the rotor. At the same time, place a curved permanent magnet on each side, which are called stators. When the current is switched on, the rotor generates a magnetic field because, like poles repel, the rotor starts to turn, but once it reaches the horizontal position, it stops due to the attraction between opposite poles. If you want the rotor to keep spinning, you need to constantly change the direction of the current in the coil to switch the polarity of the rotor. But manually switching the positive and negative wires all the time is just too exhausting, so what should we do? You, being clever, install 2 arc-shaped copper plates at both ends of the rotor coil, called a commutator. Spring-loaded carbon brushes press against the commutator, connected to the power supply. Crucially, when powered, current flows through the brushes into the rotor coil and exits the negative side, magnetizing the rotor. The rotor is pushed by the arc-shaped magnet and begins to rotate. When the rotor reaches a horizontal position, it continues to turn due to inertia, and the carbon brushes slide from one set of copper segments to another, automatically reversing the direction of the current. At this moment, the magnetic poles of the rotor also switch, allowing it to keep spinning continuously. However, there is a problem. After power off, the rotor likely stops horizontally due to magnet attraction, with brushes centered on the commutator. On restart, it won't receive power to rotate. To fix this, use a 3-segment rotor and commutator, which looks like this. When the power is turned on, coils 1 and 3 have their external magnetic poles as S-poles, while coil 2 has its external magnetic pole as an N-pole. Coil 1 is repelled by the S-pole on the right, coil 2 is attracted by the S-pole on the right, and coil 3 is attracted by the N-pole on the left. The electromagnet can then rotate clockwise, and the commutator continuously switches the polarity of the coils to maintain the rotation. Congratulations, you have invented the brushed DC motor! Do you know what the biggest drawback of brushed DC motors is? Comment below.